Hello again and welcome to part 2 of the Retro Handheld project video. In the first part I went over most of the first stages of the project and things seemed to be going in the right direction, but as luck would have it, things started to go downhill from there. I had just ordered a new PCB and had my prototype case at the ready, so I took this free time to start making a mid-project video, but halfway through the video the PCBs turned up, somewhat ahead of schedule. Being the impatient sod I am, I put the video aside and started soldering up the new PCBs, wanting to test it out. At this point I thought I was well ahead of schedule and thought I would finish the project within a few weeks. That of course didn't happen, so what went wrong? Starting off with a new printed circuit board, to save money I started with transferring most of the components of the previous PCB onto the new one. This meant I didn't need to reflash the board, and so I could get it up and running quicker. Not to mention save me a few quid by recycling the more expensive components. Each HDMI decoder chip came in at around £4 each off AliExpress, and the STM32 around £1.50. While it was a little quicker just moving all the components over, it still took me about a couple of hours to do, plus the extra time to clean up the solder bridges on the incredibly fine pitched pins of the HDMI decoder. I then got to the new backlight driver chip and immediately found a problem. I got the chip's footprints mixed up again. For some reason I didn't look more closely at the chip's datasheet and I assumed that it was a standard SOT6. But no, this chip was in fact a good deal larger and is actually a SOT89. I swallowed my pride and hacked the chip using some copper tape just to get it working. But the problems didn't end there. I powered up the new board, no magic smoke escaped and the backlight of the LCD turned on and was not flashing. Wonderful. However, nothing appeared on the screen. In fact, it was just blank white. I could see that the Pi had booted up as its drive light was flashing, but nothing was showing on the screen. At first I started to fear that I had broken my £30 IPS display. I checked the connections and couldn't find any problems, so I got out my new oscilloscope and started checking the signal lines from the decoder chip to the display. Very soon I started to find a problem. The HDMI decoder chip wasn't actually sending any data to my display, not even a display on signal, which is why the screen was white and not black. So I then checked to see if there was any signal coming to the chip from the HDMI connector, and indeed there was. I then thought maybe I had killed the chip when recycling it, so I replaced it, but it still did not work. By this point I had really started to scratch my head. I had wondered if my newly matched signal pairs were to blame, but surely it couldn't be that. If anything, they're better now than before. So I looked at my PCB design in KiCad again and then I found the problem. Somehow during the period of drawing the new signal traces to the chip and ordering the new PCBs, I had managed to delete all the ground lines to the chip, so it wasn't even turning on. After looking into ways of somehow trying to wire 16 0.5mm pitched ground lines and realising it's just not going to happen, I then had to accept I wasn't going to be able to salvage this revision of the PCB, and so corrected my mistakes for a new PCB order. However, I didn't order a new PCB right away, as during the time I was working on the mid-project video I had started to come up with some ideas of how to improve the design. I realised I actually had a lot of unused space inside the grips. While currently I use some of this space to place some small box speakers I had, I figured out that with some tweaking of the design I could in fact fit an 18650 cell in each of the grips. Modelling the cell in Fusion 360 and checking the fit with a cross-section tool, I knew I could make it work. I was also aware it was possible to find legitimate high-capacity 18650 cells, though the trouble was where from, as the market was flooded with fake high-capacity cells, some obvious and some less obvious. After calling on some advice from various members of the Freenode Electronics IRC channel again, I was then told about a site based in the Netherlands, en.encon.nl. This was recommended to me as a trustworthy site to buy legitimate high-capacity lithium-ion batteries. Looking through the site, I ended up settling on an LG brand that had a rated storage of 3500 mAh each. Fitting two of these into my handheld would give me a rated storage of 7000 mAh, which was fantastic, as my old battery choice was only 5000 mAh. And to sweeten it even more, they were really cheap, far cheaper than the flatback batteries I had already got. I can only assume it's because they don't have any built-in protection circuitry, which is fine as I already had it on my board. With the large flatback battery out the way, I could then do something about the rather oversized battery bump I had in the middle of my case. And after a fair amount of remodelling, I managed to reduce how much the bump came out, though I kept just enough to fit a cooling setup and the new speaker chamber. During some earlier tests, I found I was less than impressed with the quality of the audio coming out of the miniature box speakers I had, and I started to experiment with a resonator for one of the larger speakers I had ordered. On their own they were oddly tinny, but adding a box to the back suddenly brought out a much more richer sound. Though still not hi-fi and some frequencies will resonate annoyingly, they're a lot better than what I had before. I'm not an acoustic engineer, so I don't know the maths or science to achieve a higher quality sound, to which I'm sure many would say I'm doing it all wrong, but I had something I was actually happy with. As for the cooling, before I had wondered if I was going to have to make a really complex heat pipe setup, but thankfully after this design change I was able to fit a standard Pi heatsink and figured out a side-blown fan for the job. Finding the right fan was a little harder, and I think any future versions I might end up changing it again, but for now, after testing some of the miniature fans I had, I settled on this blower. I'm not entirely happy with the choice. While out of the few it had the best performance, it also drew more power at full pelt, sucking up 200 milliamps, though would settle down at 160 milliamps once the bearings had warmed up, and I had always planned to do a PMW control for this fan and hoped I wouldn't need to run it at full speed anyway. But a little more on that later. I had finished my design changes and tweaked my PCB, so off to JLC for another order. I needed to print out my newly designed case, and it was at this time I decided to try and get hold of some tough resin. As some may know, standard UV resin used in printers like my Anycubic Photon are incredibly fragile and brittle, prone to shatter if you stare at it too intensely, so I had to find something better, and this is where the money really started pouring out of my pocket. I was hearing good things about Soraya Blue tough resin, and so I searched high and low for it. Eventually I managed to find it being sold on Amazon.com. At first glance it looked like a really good deal, around $50. After conversion that meant close to around £35 to £40 in the UK, which was roughly the same price as normal resin sold locally. But after shipping and prepaid import tax was added to the order, it came up close to £80, which stopped being a good deal. However, I needed this resin, so I placed the order. So I waited, twiddling my thumbs, and by about week 3 I stopped being patient and contacted Amazon customer service to find out where my order was. After a few more days waiting, I finally got a reply from Amazon.
You've got mail.
It turned out my package was refused by UK customs and returned to the USA, and Amazon just didn't tell me. As for why, I still have no explanation. Amazon told me to contact customs, and customs told me to contact Amazon. And while in the end I did get a full refund for this order, it took over 2 months for me to get all my money back, so for this period I was extra out of pocket and still in need to buy resin. A little while later I was recommended another resin from a company based in the EU, fun to do, Deep Black. This resin came in at £60 per litre, but it was also recommended to me to get their cheaper resin too and mix the two together to get the best results. But their cheaper resin also came in at £40, and by this point I was getting desperate. So here in the end I made the £100 order for resin. And what a waste of £100 that was. I ended up using nearly all the resin trying to print out the new case. I had failed print after failed print, mostly due to the resin not adhering to the build plate and falling into the vat, which I've put down to the resin sweating after cure, causing a film to appear between the print and the build plate, something the manufacturers say does not happen even when I showed them photographic evidence of it. But also this resin warped, and it warped bad. If not warping during the print, it would warp post-cure. So when it was time to glue 2 halves of each face, they won't meet correctly. By this point I was massively over budget for this project, and I did not want to spend any more money on it, so I made do with the case I have now, which still has some warping but is good enough to get the job done. I wish I could recommend this resin, as the final printed look is nice. Like its namesake, It has a deep black look which makes it appear like injection moulded plastic, and it is indeed a bit tougher, but for anything other than small print I really would never go near this resin again. I have since started using Elegoo's ABS-like resin, and while currently I only have it in grey and printed relatively small parts, I found this resin to be really good, as it appears to have a very low warp, even bridging straight between support struts, and indeed it feels tough like ABS. When trying to snap the support struts they would bend and feel less brittle. It's also available at a reasonable cost in the UK, so it's likely for anything big I'll be using this resin in the future. I would like to say I'm not sponsored by anyone I have mentioned here, but if Elegoo are watching, please sponsor me. I really like your resin, and I'll put it to good use. Yeah, that's not going to happen. Anyway, I did have a working case and the new PCB arrived and was soldered up, and as far as I could tell, was working perfectly. Well, almost. I still did make one mistake. It's not a showstopper, but it was enough to be mildly annoying, and it broke one of the features I had in mind for this design. It was the OTG connection. While the USB port worked fine for charging up the handheld, I had also wanted this port to be a functioning OTG port, so I could touch a keyboard, a storage device or another controller. But I forgot to come up with a way to power the 5V pin without looping back into the charge circuit, so there was no way to power any external device. This was simply something I overlooked and was not bothered about enough to make yet another revision. So let's finally have a look at this thing. As you can see, it sits comfortably in my hands, the buttons feel good to press and the analog sticks are also easy to reach. However, while the shoulder buttons look and feel good to press, where I've placed them means I do kind of need to arch my forefinger to press them with my fingertip, but that's just probably me nitpicking. And as I mentioned earlier, this print is also warped a little. While not immediately obvious, you can see here at the bottom of the screen that the bezel is not perfectly aligned, and here at the sides, the grips, and down the front. The two halves of the case don't quite meet perfectly. And also during early testing I managed to actually snap the bezel here in the corner, but I have managed to superglue it back and reinforce the underside. One last major issue is the power toggle, which you can see here is currently missing. This is because in this revision, every time I tried to put it together, I ended up snapping the toggle switch inside. Now, with all these problems, I'll be in my right mind to make a revision for and correct them, but like I said earlier, I have spent far too much money on this already and I didn't want to spend any more. Besides, I had TCT coming up in September, which I wanted to show this thing off at, to see if I can find any work as a designer, so I had to make do with what I had. Though I did make some corrections and changes to the design, such as better underside support in the bezel to fix the weak point, and having a toggle switch separate from the main board connected via a wire, but those will be implemented in the future version. Let's turn this on. You can see the LEDs chasing. This happens till the USB host is detected. And then the LEDs display the battery level. Now, while on the subject, let's talk a little bit about the HID development. I'm using the popular STM32F103 microcontroller. It has a built-in USB port which not only can be used to program the micro, but also can be used to make a USB device with. I have used Rogerclarks Popular Core and the built-in USB composite library written by Alexander Pross. My original plan was to use the Xbox controller portion of this library, but with Alexander's help we discovered that the Xbox driver would not allow for USB composite. I wanted to run two USB devices through this port, the game controller and the volume controller. The volume controller is part of the consumer portion of the library that runs media controls. With Alexander's help we managed to get both the generic controller working along with the volume control. But we also had to make changes to the library, not only editing the USB descriptor for the generic controller, but also the order of the data stream. Originally the library had the analog stick spit out data at a 0 to 1024 value, but I discovered that in RetroOrangePi, game controllers needed a negative to positive range for them to work correctly, so I edited the descriptor to reflect this, and Alexander told me where to change the data stream values. Again, a massive thanks to Alexander for helping me getting this working, but also for providing a really amazing library for the STM32. I then had to write filtering code for the sticks and buttons and then the screen brightness controls. To change screen brightness, you hold down the option button for 2 seconds and then the LEDs will flash with the screen's current setting. There are 6 steps, up or down, to change the brightness. I do plan to make this a little more refined and even automatically lower brightness when the batteries get low, but I'll leave this for now. As you can see, it's running a port of RetroPi called RetroOrangePi. This is a port of the popular system made to run on most Allwinner based boards, and luck would have it, was getting a release candidate just as I was ready to start installing it. And again, a massive thank you to the developer for this port, for the help he gave me getting this to work on my board. This took a little work and wasn't perfectly straightforward, needed to make some edits to some config files, so it would run on my non-HD display, and play audio through the analog ports of the Pi. A link to RetroOrangePi is in the description. As you can hear, the audio certainly doesn't lack volume and can get surprisingly loud, and while there is no distortion, there is some harmonic resonance that might get a little irritating at higher volumes. I would love to turn this down via the main controls, but there lies another problem. While there is no problem with the HID side of the volume controls, Linux doesn't automatically support it, and I still need to figure out a way to get the controls to set the system volume level. It does work in Windows, and even the codey portions of this Linux build react correctly to the volume change commands. Performance wise, it's not too bad, though not as good as I had hoped. 16-bit gaming like the Mega Drive or Super Nintendo is near flawless, but I did notice an ever so slight slowdown when Sonic loses a large amount of rings. Nintendo 64, however, is sadly unplayable, as is the PSP. While they do run, the frame rate is around 15 FPS, which is really disappointing, and I would have thought it would run better. The curious thing is though, during these tests I'd monitored the CPU usage in Ambient Monitor and noticed that the CPU wasn't really running at full load, so I suspect the issue might be software rather than hardware. But I don't know RetroPi or even Linux well enough to be certain, least of all know how to fix it. This of course is really disappointing, as I really would have loved to have played titles in these formats. Game Gear, Game Boy and Game Boy Advance all work perfectly as well. I've not been able to test Neo Geo games yet because no games have managed to run, but I've been told I might need to find a working BIOS file, and there might be some other fiddly bits to deal with, but again, I've not had time to sort this out. PS1 games also worked flawlessly and I didn't experience any dropped frames, though I didn't test any reshading or upscaled features, and just used the default settings inside the emulator. Quake 1 seemed to run perfectly fine as well, however the game doesn't seem to recognise my controls at all, so I can't play it. And to get out of the game, I need to turn the handheld off and on again. I need to do some more research on how to fix that. I also would really like to try a port of Quake, as that always looked better. My cooling setup also seemed to be working perfectly. The fan is PMW controlled via the Pi, and I had written a script to increase the fan speed as the CPU got hotter, with 50C being the fan turn on temperature. Even in Quake, which ran smoothly, the temperatures only got a little over 55 degrees C, so the fan stayed at its lowest speed, and only after about 30 minutes did the temperature start to reach 60 degrees, so I certainly have no fear of throttling kicking in. With the general performance out the way, how good is my battery setup? Well, like I mentioned, this is a rated capacity of 7000 mAh. What it actually is, I couldn't tell you, as I have no way to fully test. But these are genuine batteries, so it would be fair to assume they are near their rated capacity. So I set up my old camcorder and filmed the handheld running Super Mario World. Now, I wasn't going to film me playing this all day as I had other things to do, so I just let it cycle through the front menu. And I got about 5.5 hours when this happened. Now, what I was expecting was the handheld to just power off, but it seems my over-discharge protection circuit needs a little tweaking, as I think its cutoff might just be a little too low, at least below the DC's to DC's input voltage rating. But on the plus side, I did get 5.5 hours of usage at full charge. But here is where things went downhill. I set up the handheld to charge it back up off my bench power supply. I hit record and plugged it in. and as you can see, it did not charge up quick at all. In fact, it took 7.5 hours to fully charge up this handheld, which was a massive disappointment. During earlier tests, I was using the handheld plugged into my bench power supply, and I measured over a 300 mA jump in current between when it's just charging and when I've turned on the handheld. So I don't think there's actually a power deficit, but just for some reason the charge control chip is not allowing my supply to provide the 2 amps that I have set it to. But as you can see, it would only draw 1.3 amps at the very beginning and slowly come down as the battery charges up. Strictly speaking, these two 18650 cells sitting in parallel should be able to take a max of a 1C charge rate for fast charging. So with a 7000 mAh capacity, that will be a 7 amp charge current. Now there is no way I can provide that over USB, but the charge circuit was not allowing the full 2 amps it was meant to. So this is obviously a massive disappointment and something I need to look at again in a future design. Let's have one last quick look inside the handheld and go over what's inside. Taking this apart, I do need to be a little careful as some parts are a little fragile. Right, I do apologise for the mess of hot snot, but it was required in order to help sort out some of this wire routing for the parts. Okay, let's first say the two 18650 cells, they are 350 milliamps each. We've got 2 different types of speakers. They're actually slightly different wattage, and I had to add a resistor onto this one to match. This is a standard round box speaker, and this is my custom speaker with the custom resonator there. We have the cooling fan, which is wired to the Pi, getting power off the Pi port and the PWM signals coming off the pin there. Over here we have the shoulder buttons and their PCBs. Originally these were spring supported, but in the end the buttons on their own felt much better. So here we have the RetroOrangePi with its cooling, the USB that was connected to the OTG, but that hasn't happened. Underneath here we have the audio amplifier. This is the capacitive touch controller, connected via USB and routed towards the Pi. Here is the HDMI decoder chip with my HDMI connector, power for 3V logic, and the backlight controller circuitry. This is all power and filtering for the HDMI controller chip. The 2 WS2811 chips that control the 6 LEDs underneath. The STM microcontroller, which runs all the HID. We have the charge chip with its inductor that basically charges up the batteries. We have the DC to DC chip with its inductor, and that runs all the 5V power and everything there, and a couple of power MOSFETs that deal with power switching from when I run the switch here. Let's take this apart. Here we have the 2 analog sticks and the so 800 by 480 capacitive touch display. And all the printed buttons on the inside. So what are my final thoughts on this handheld? While there are issues with the print, I do think it looks and feels good to hold. It is hefty though, weighing in at 500 grams and certainly doesn't fit in your pocket. As planned, the design does look like a nice throwback to late 80s and early 90s console gaming. Performance is decent, though not quite as good as I hoped. I had hoped that the PSP and Nintendo 64 and even at a stretch Vita gaming would be possible, but currently with the H3 version of this board I can only get choppy performance at best with PSP and Nintendo 64. Sadly, there are currently no plans for RetroOrangePi to be built for the H5 version of the Pi Zero I am using. The two shader cores in the H5 variant may have given me the performance boost that would have made the PSP and Nintendo 64 run better, but at this stage I can't be certain. And then there's also the breaking toggle switch, but like I said, it will be easy to correct in another design revision. And as I previously mentioned, the charge system is slow, and I can certainly try to get it to charge faster, and it's something I will look into again in a future version. And talking of future versions, thanks to the interest I've received from a decent number of people asking me if I'm going to sell this handheld, I have looked into ways of making it possible. During the development of this project I have looked into injection moulding and have considered every business possibility to make it work. However, I have struggled to find any way of making it possible to sell this en masse without leaving me heavily in debt. I have had a range of quotes for injection moulding, including some as high as £50,000, and even the more reasonable quotes I have had would make it impossible for me to break even on sales, let alone make any profit, or even be able to pay myself a wage for all the time and effort I would have to put into assembling the units. These costs would have meant I would have to charge a far higher price than the market value for such a device, so I had to knock that plan on the head. But it's not all doom and gloom. I have made a promise to all those who have showed some real interest in Bioman that I will figure something out. So here's the thing. Since the release of the Raspberry Pi 4 there have been rumours of a compute module and zero version of this computer being developed, and when I went to TCT last September I met some business partners of the Raspberry Pi Foundation who gave me a wink suggesting that the rumours might indeed be true without openly confirming them. Either that or the person I was talking to had a facial tic. So with that in mind I have agreed to develop a Pi 4 version once the new smaller boards are released. It has been suggested by many people that I set up a GoFundMe or Patreon to help me cover the costs of the new development project, and so I will. I would also be looking at ways of doing resin casting of the main case of the handheld, a reasonable, cheaper alternative to injection moulding, but this does take a fair amount of manual work and so I will only be able to produce a handful of units, 10 or 20 at the most. I for one am actually very glad to be done with this project for now. I will work on future versions in the future, but for now it's time to move on. So what's next? Okay, yes, this one has been on my mind for a while, and compared to this handheld it should be a far simpler and cheaper project to build. I'm going to be making a working miniature of the Stargate from SG-1. I plan to make it roughly 1.5 feet in diameter, and it will have a spinning internal ring and locking chevron effect. I have yet to fully design this, but I have been coming up with ways this could work in my head. Again, I'll mostly be printing the parts, but I may also choose to use my laser cutter once I have finished getting it to work. I made a CG version of this over 10 years ago, but since then I have come to realise just how inaccurate my old model was, so I will be redesigning this from scratch using more up-to-date reference material online, and hopefully it should be a decent model to keep on display. Now, if you like my projects and want to keep updated, please subscribe and hit the like button. No idea what this will do for me as I don't currently get paid by YouTube, but hopefully I'll get enough interest in time that my projects can start paying for themselves. I also want to thank all those who have recently subscribed to my channel. This bump in views and subscriptions has really given me a nice confidence boost and drive to get on making more projects. I hope you enjoy this project, and I'll see you in the next one. Thank you for sticking around through this rather long video. Goodbye and take care.